Okay, welcome back. Let's talk about some connectionist classics. The first one we're going to look at is called Jets and Sharks. It's the Jets and Sharks network. And what we have here is something that does not learn. It goes back to the early 80s, and it's a network that is going to keep knowledge of members of two gangs that are taken from the musical West Side Story, and the uh, programmers. McClelland has just imagined some statistics for these people. So you have Ralph and Lance. These are the names, and they go directly to the instance nodes. This, by the way, is just a sample of a larger set. So we don't have the entire network here, just a snippet. And and then these tie to, well, you have different pools, different properties like age, 20s, 30s, 40s, and then I guess specialization, burglar, bookie, and pusher. And then down here you have marital status, married and single and divorced, and then which gang that the person is in, jet or shark, and highest level of education achieved, junior high, high school, and college. And what you can do with this is probe one of these nodes and find out other information about whatever that node represents. These are called the instance nodes or the exemplar nodes. The connections between these nodes, like the name nodes or the age nodes, etc., the connections that go outside of one pool to another are mutually excitatory. So if Lance is excited, this node is excited, and that excites the name Lance again, mutually excitatory. Looks like Lance also, the instance node, excites junior high, right? So then junior high gets more excited and the excitation goes right back. You can see that these arrows are on both ends. That means they're bidirectional connections. Bidirectional connections between nodes of different pools are mutually excitatory. But then within some group, you call that, these are inhibitory or competitive. So if junior high is being excited, then junior high will inhibit college and high school. Meanwhile, if Lance is being excited, Lance will inhibit Art and Rick and then the others. In other words, they try to compete with each other within the group, because if your highest level of education is junior high, then of course it's not college or high school. If you're a jet, then you're not a shark. If you're single, you're not married or divorced, etc. Right? And so connections between units within these groups or these pools are mutually inhibitory or competitive. And you can cross-reference all this with the Jeff Yoshimi movie video that I linked as well, that shows you how you can uh, uh, how you can do this on his program SimBrain. Now we're going to probe names. So we could probe art, and if we do that, that is, we activate art, which in turn activates this instance node, which then activates single, jet, pusher, 40s, I guess. It's really small on my screen, and junior high. When you activate Rick, you will get to this node, which activates 30s and burglar and divorced, etc. So let's see how that works. Yep, Jets, 40s, junior high, single, and pusher. And then Rick is in the Sharks, 30s, high school, divorced, and burglar. That shouldn't be too surprising. We can also do this. We can probe Jet. So instead of probing a name here, or maybe directly probing an instance node or an exemplar node, we're going to probe Jet. And that's going to give us statistical information about your typical Jet. And here's what we get. Most of them are in their 20s. So a randomly selected Jet is with 2 out of 3 probability going to be in his 20s. In junior high, these all happen to be 66%. Down here, evenly distributed. This, by the way, represents the entire data set, not what we have here. Because how many jets do we have? We have 4. So how does that make any sense that pusher, burglar, and bookie are equally distributed? I haven't stopped to go through this, but apparently there's one occupation that 2 jets have, I guess. Anyways, again, this is just a snippet of the larger net. All right, now Harnish has characterized these features of Jets and Sharks. You've got just units and their connections, so it's a stripped down, very basic neural network. You have representations here, so each unit represents an individual, like these, or a property, like being in your 20s or having completed college, etc. The program is just to connect everything, specify how each unit passes activation and inhibition to other units. And this is also made clear if you watch the video of Jeff Yoshimi's SimBrain. These things do not learn, as I already mentioned. They are not trained. You just set them up this way.